isu elektrik ni dekat angkasa ni, dia bukan saja satelit, sama juga dekat bulan, dekat planet Marikh juga. Example dekat bulan, baru-baru ni India punya space program ISRO, where they became the, I believe, the third country, the fourth ever country to land on the moon.
First to land on the polar region, right?
Well, exactly, dekat South Pole punya region. Tapi disebabkan waktu malam dia panjang sangat, like kalau dekat bumi, waktu malam kita dalam 12 jam. Kalau dekat bulan, waktu malam dia 14 hari. Lama sangat. So kalau 14 hari, sumber elektrik nak pakai solar panel, tak ada matahari pun, tak ada elektrik. So lalas habis 14 hari tu, 14 hari malam tu, nak turn on pun dah tak boleh dah. So that's why dah banyak mission semua terbantut, semua dah space mission ended hanya sebab isu elektrik. So that is why for Afilia, we are trying to solve that issue. Dari segi kompetitor, dalam tahun 22, dalam dunia ni betul-betul yang serius ada dua saja startup. Satu Afilia, kita daripada Malaysia, lagi satu daripada UK, namanya Space Power. But long story short, throughout year 22, the ex-co-founder, bekas pengasas untuk Space Power tu, our competitor, our only competitor masa tu, kita orang contact, and that guy eventually join kita orang as an advisor. Dia join kita orang sebagai advisor, and we have discussed a lot of things among ourselves, including our company's own direction. We genuinely believe that, like, even untuk low Earth orbit, banyak satellite, the market is big, tapi we believe that the market is even bigger dekat bulan. So that is why right now, while we are solving the technical challenges untuk low Earth orbit, we are also entering the moon market right now.
You are planning to be like a grid kind of thing?
Yes. Exactly, like contoh macam TNB, bina pencawar elektrik semua, tapi bezanya adalah untuk apa kita nak buat dekat bulan, kita tak buat macam wayar, kita buat wireless. Dia bezanya adalah kita nak supply ke electricity daripada kawasan macam Siang untuk deliver electricity wirelessly kepada kawasan kawah-kawah bulan yang memang gelap. Sebab di situ semua sumber ekonomi dekat bulan ni adalah air. Dia bukan air, dia ice cube lah, water ice. Sebab water ice ni penting daripada hidrogen, oksigen manusia nak bernafas, sebab tu penting. Tapi water ice ni banyak ada dekat kawasan yang gelap saja. Dekat kawasan gelap nak ada solar panel, solar electricity memang tak boleh. So that's why kita deliver electricity kepada apa-apa mission.
So at what stage is the technology right now?
So right now, kalau dari segi technology readiness level, daripada 1 sampailah 9, I believe 9. So we are entering at stage 3.
What does that mean?
Trigger meaning we are building the working prototype. It's like the proof of concept of technology kita.
Proof of concept lah sekarang.
Of course, kita sekarang awal, tapi honestly, there is a main difference between style Malaysian and also the rest of the world. Sebab when it comes to membina startup yang berasaskan teknologi, yang R&D dia memang agak intensif, we have to talk to the customer first before kita start R&D. Sebab R&D ni not only is very hard, but also menggunakan banyak sangat duit. Jadi apabila customer pun tak ada, kita bina je teknologi, contoh dah belanja 5 tahun, dah belanja berjuta dolar dah, tiba-tiba awak bina teknologi yang salah, customer pun tak relevan. Why you are building this? It doesn't bring any value. Even yang tu, that's the worst case scenario. Even like similarly like least worst case scenario, like our competitor, Space Power dekat UK tu, who eventually joined us.
Kenapa dia give up?
Dia orang tak give up lagi. Tak give up lagi. But there is a huge challenge for them. Beza kami, Afilia, and also that company, Space Power, even there's new competitor sekarang ni buat style lebih kurang sama dengan Space Power. Bezanya adalah dia orang pakai laser. Dia orang pakai laser. Kita pakai radio signal. Microwave. Laser isunya adalah dia orang dah dapat government grant a lot, like millions of pounds, bina teknologi, buat laser, menjadi like from a point, deliver laser power to a receiver. But there's an issue. Apabila when they are talking, nak dapatkan approval daripada regulatory body dekat US panggil FAA, They were mad. They were freaking mad at these UK companies. Do you know why?
Laser.
Because laser, kalau buat high power, is a weapon. No argument, is a weapon already. The last thing we want is Star Wars dekat angkasa. Semua piu-piu-piu perang dunia ketiga dekat angkasa. That's the last thing we want to do, to happen. And so now, diorang bina teknologi not only to customer. Before buat R&D tu, regulation body pun tak bincang dulu. Then the money gone. So it's like the challenge here, apabila I believe all the research can understand. Bila nak ubah,
so you're right. So high powered laser boleh jadi weapon. But high powered microwave also boleh jadi weapon.
Okay. So, you're totally correct. You're totally correct. This is a dilemma for us, which makes an even better case to go to the moon. Tak tahu ceritanya. Okay. Laser boleh jadi weapon. Orang kata laser nak pergi ke customer base satellite. Laser ni orang kata sampai berlubang lah. Okay, berlubang. Microwave, it can be a weapon, but dia sampai ke tahap kita panaskan. How convenient. Kita tak nak lah macam terpanaskan customer punya satellite sampai hangus semua. Maksud kita kena saman, Malaysia kena saman pula kan. Tak tentu pasal pula kan. How convenient. How convenient dekat bulan, bila waktu malam tu, dia punya sejuk tu, which is a bad news for space company yang pergi ke bulan. Dia punya sejuk tu can go as low as negative 200 degree Celsius. Negative 200. And
sikit lagi you get liquid hydrogen.
Sorry?
Sikit lagi dapat liquid hydrogen.
Itulah. Betul. So banyak komponen-komponen elektronik, actually anything lah, tak boleh operate sampai sejuk-sejuk sangat negative 200 degree Celsius. How convenient for our case. Not only kita provide electricity, we can also tolong panaskan
remote heating.
Equipment.
Remote heating.
Yeah.
Okay. Okay. so dia punya cerita dia sekarang ni you are building a prototype to be tested on Earth dululah.
Betul, precisely.
And how far away are you from completing the prototype?
Yeah. So right now, alhamdulillah kita dah dapat Cradle punya funding, which thank you Cradle. Okay. Alhamdulillah. But because of the funding is quite limited for our case, 100,000 ringgit, insyaAllah within quarter 2, either bulan 5 atau bulan 6, we will be conducting a ground demonstration dekat Sirim insyaAllah. Dia memang kecil je, jarak pendek je. We are talking about 50 cm je, setengah meter. Okay. Memang kecil. But just to share, this is where our thought process is different. Orang lain, our new competitor, actually there's only a few, ada 2-3 saja. Ada Canada, US, dekat UK. Diorang bina prototype, okay, buat long range. Wow, buat long range diorang boleh buat. But of course, nak bina prototype long range tu mahal. But when we talk to customer, betul-betul paling penting is not just a wireless range. Paling utama sebenarnya dua benda. Can you make the size smaller, and also number 2, can you make the nak transmit electricity, the entire system to efficient? Because it doesn't make sense you can go say even 1 juta kilometer pun, dia punya efficiency tu sangat rendah. So it doesn't make sense. Sebab bila kita convert ke unit economics of it, cost per kilowatt hour is very high. So we are talking about, okay, let's say customer nak 100 watt, tapi disebabkan efficiency kita sangat rendah, customer nak 100 watt, kita kena pump 1 kilowatt. This is not good news. So that's why for our case, the prototype that we are currently building, that we will be demonstrating, our main point here is not to show that we can go long range, but we are showing that we can make our system way smaller and also way efficient.
What's the target? How many percent efficiency are you looking at?
The best in the world right now is 30%, 30+% daripada US. Our goal as of now, the maximum is 70%. But we do expect kalau dia jadi lagi rendah, we are talking about like 50 to 60%, which is still way higher. And just nak berkongsi apa beza teknologi kita dengan yang orang lain yang buat microwave juga. So sebab tadi earlier in our conversation, we are comparing antara us microwave dengan laser. Tapi kalau comparing kita punya microwave punya teknologi dengan microwave yang lain, apa bezanya?
Apa beza?
So diorangnya microwave, diorang buat frekuensi 10 GHz. So maybe doesn't make sense, but yeah, just take that in mind. 10 GHz for us, kita buat lagi tinggi frekuensi. And difference is that bab kalau RF engineering ni, kalau sorry for being technical lah kan, frekuensi kalau lagi tinggi, nak design tu lagi susah, terutamanya nak bagi lagi efficient.
Okay, so kenapa you pilih yang lebih tinggi?
Sebab nak buat size tu lagi kecil.
Size apa?
Size antena tu sendiri.
Kenapa boleh lagi kecil bila frekuensi lagi tinggi?
Sebab kalau frekuensi lagi tinggi, kalau spesifiknya dia wavelength lah. Wavelength dia lagi halus. Apabila wavelength lagi halus, antena tu boleh lagi kecil.
I see.
Yeah. But in terms of nak manufacturing process dia, sebab dia halus, bukan saja manufacturing process, but also efficiency dia sangat susah nak bagi dia masih tinggi efficiency dia. Sebab biasanya kalau frekuensi lagi tinggi, efficiency dia lagi drop biasanya. So that's why we managed to solve already.
That's what it means lah. The longer the wave, the farther it can go and sustain dia punya energy, right?
Yes.
The shorter the wave, it can carry more intensity, but it cannot go far.
Exactly.
Okay.
But just to share, for communication, macam BBC radio news and all, bila frekuensi lagi tinggi, it can go dekat saja. Sama juga macam 5G sekarang kan, macam menara 5G coverage dia kecil sebab frekuensi dia tinggi. But for the case of menggunakan radio signal untuk tenaga, bukan untuk komunikasi, untuk tenaga, dari segi teori tu kita panggil beam collection efficiency, BCE. Kalau frekuensi lagi tinggi, you boleh pergi lagi jauh sebenarnya. Dia terbalik. Untuk komunikasi macam 5G.
Because yang tu dia pergi omnidirectional lah.
Exactly.
So now you are working at 100 gigahertz.
We are now working at 24 sebenarnya.
24.
Yang orang lain they work only 10. Up to 10. Kita orang more than twice.
More than twice. Okay.
More than twice.
So you're looking at 24 gigahertz sekarang. So at that 24 gigahertz, you're targeting 70% efficiency.
Correct.
Correct. So apa dia punya drawback? Dia mesti ada drawback dia kan? What's the drawback? You require bigger equipment ke, use more power ke, apa dia?
One of the short term drawback is kalau nak buat R&D tu untuk high frequency ni, equipment kita pakai ni memang mahal. Ada satu equipment ni panggil oscilloscope. Oscilloscope ni apa functionnya? Kalau kita buat circuit, kita nak tengok elektrik dia, apa dia punya karakteristik. So our case, oscilloscope biasa contoh harga RM2,000 boleh dapat daripada China. Tapi for our case, sebab frekuensi dia tinggi sangat, that equipment saja it can go to $300,000. Really expensive.
I see.
Really expensive.
Cost is higher lah ceritanya sebenarnya ni.
The R&D cost itself is way higher. And also of course the design itself memang sangat susah. But that's where for our case, apabila kita compete dekat taraf global ni dengan competitor not only from the likes of US and the Americans and the UK and the Japans, it is important for our case to macam mana pun we have to figure out how to make it cheaper our situation, but also work at a really high intensity technology capability to compete with them. So for the case of equipment mahal, for our case kita tak beli, so kita sewa ataupun kita work with any existing facility dekat Malaysia
yang ada
yang dah ada equipment dulu.
So you're looking to have that prototype ready this year?
We are planning right now sama ada bulan 5 atau bulan 6.
Okay, so the next step, once you dah able to produce this and prove, what is the next step lepas tu?
Good question. So for this year, in terms of technology progress, this year our goal is to fine tune our prototype according to our prospect customer. Customer kita dah ada requirement, kita fine tune kita punya prototype berdasarkan kehendak dia orang. And then next step tahun 25 and also 26 is where kita nak buat teknologi demonstrasi dekat angkasa. At least 3 mission. Mission 1 dengan 2 around bumi juga, low Earth orbit juga. Third punya teknologi demonstrasi is on the moon.
It's on the moon. Who's flying to the moon in 2026? Ada ride pergi ke bulan ke 2026?
Ada. Jawapannya Mas Elon juga.
Mas Elon juga. Okay.
So,
Mas Elon is going to the moon in 2026.
InsyaAllah.
But that's like on a NASA punya budget ke siapa tu? Ke dia ada ride sharing masa tu?
Ada ride sharing juga. So for our case, kita bukan directly dengan SpaceX tumpang naik roket SpaceX. We are working with a specific US based space company, a moon company actually, which alhamdulillah kita dah secure agreement dengan dia orang. It's called Astrolab.
Oh, Astrolab, okay.
Yeah. So what they do, they are do two things. Their main business is they are building a huge rover, satu kereta besar untuk dua. Ada satu astronaut boleh duduk atas kereta tu. Another one is apa-apa barang semua orang nak sumbat tumpang dalam kereta tu.
I see.
So that's where kita punya teknologi demonstrasi which we are working on. Kita tumpang masuk dalam kereta diorang, Astrolab punya kereta, where this kereta itself akan duduk dalam SpaceX punya rocket.
Okay.
And this SpaceX punya rocket is not the for all the space fan, siapa yang nak tahu dekat luar, yang nak pergi ke bulan bukan pakai Falcon 9 punya rocket yang rocket sekarang ni. Is a latest new rocket panggil Starship.
Okay.
That Starship is the biggest ever rocket that is currently being built by human beings.
So that is in 2026. 2025, the technology demonstrator dekat satellite tu dengan siapa? Yang tadi tu dengan Astrolab, yang dia dengan Spacesium lah.
Dengan untuk low orbit is not finalized yet.
Bila partner dengan Spacesium tadi kata?
But not exactly untuk nak launching tu belum lagi.
Launching belum lagi.
Betul.
So yang 2025 ni Spacesium akan launch dia punya R&R tu lah.
Betul.
So you will be a component on that R&R.
Exactly. Yeah.
So dia orang punya cerita, since the client satellite is coming to their satellite, what's the distance that you're working on? Clearly dia nak kena ada physical contact kan, dia nak transfer.
Betul.
Physical propellant kan.
Betul.
Is the 50mm good enough?
Actually, as long bila dah jarak 1 km tu, kalau in the short term lah, 1 km dah boleh charge dah. Sementara dia tengah nak docking pun kita dah boleh charge dah.
Okay, but they will be docking for how long? If they're docking for like a few hours, you is that 50 meter yang you cakap yang nak buat kat sini, is that the distance that you're looking, are you gonna be? Macam mana?
Yang tu, there's a specific number how long they need to take in order to refuel, but definitely that is actually enough lah. Sebab semasa di docking makin lama makin dekat, kita boleh je lagi best lah contoh, sebab jarak dekat.
So why would you transmit energy when they're far, when you can just wait until they come in contact?
Boleh juga.
You'd be wasting energy dah over logical distance.
As long as kalau dah masuk coverage tu boleh dah.
So the efficiency tak ada improve dramatically as they come closer?
Yes, actually improve. Sebab dia makin lama makin dekat, jarak tu kita like efficiency tu memang lagi increase. Sebab lagi dekat dia lagi efficient lah sebenarnya.
Right.
But the specific details of our bilateral partnership dengan Spacesium is actually it doesn't include specifically kita nak launch sama-sama dengan dia orang. The partnership itself entails what is the kind of like the transaction is. So for our side, apa yang kita like buy service from them, if dia orang robotic arm installkan receiver pada satellite lain.
I see.
And then what they are kind of like buying from us is diorang punya charging station dekat R&R diorang tu akan pakai teknologi kita orang.
I see.
So in terms of kalau year 25 kita nak buat teknologi demonstrasi around the earth, bukan bulan dia, around the earth, that is where we are still exploring lah. So apabila kita pergi ke US, we have talked to some companies, we are exploring on that lah.
Right. But you are confident that in 2025 you'll have something to space demonstration and very kilowatt power level already.
For that, definitely dia punya spesifikasi tu lagi rendah lah. Maybe only a few watts, also jarak pun lagi dekat. But when it comes to confidence, if I may share, of course this is a extremely high risk. When I was listening to interviews of not only like NASA scientists, engineers semua, like diorang pun lagi dahsyat, risiko dia lagi tinggi. Diorang bina satu teleskop ni berbilion dolar punya harga. It's called James Webb Space Telescope. WST, which dah berjaya dah lah. Apabila this interview tanya dia, how confident are you? Bila yang ni lancar semua everything goes well. Jawapannya adalah, when it comes to confidence, actually my own interpretation is not a reliable kind of like measurement. How confident are you boleh berjaya ni? But rather secara accuratenya, what we do is every time apabila kita risau, risaulah part ni nanti kalau tak menjadi macam mana pula kan. It's okay, go dissect what are you worried about. If it is legit worry, you have to solve it, find the solution. If it is not legit, it's okay, just go sleep. Sometimes like that is why like physics ni, hukum physics ni is like Elon say, physics is very unforgiving. No matter how confident you are, orang kata if dari segi Islam, kalau ittaqullah, kalau tak jadi memang tak menjadi. So that is why for our case, we don't really, at least for me, learning from this kind of NASA scientists, we emphasize more on really the technical risk aspect rather than how confident are we, because it's also very subjective. Kita confident ke tak, even 100% pun, there might be technical risk that we are not aware of. That's where the mentality is a bit different now. So yeah.
The space industry is also undergoing a huge revolution lah, thanks to rocket yang boleh turun balik kan.
Betul.
And that makes space launching a lot more affordable lah.
A lot more.
Not cheap but affordable lah at least kan.
Yeah.
How is that changing the way that you're thinking about this? Because now I mean, there are 3 rockets a week going up.
Yeah.
Masih lah nanti 3 roket seminggu kan.
Exactly.
So it's almost like a schedule already. Boleh tunggu seminggu 3 kali. Kalau tak naik 3 kali, you're wondering, was it the weather? Was it what's going on, right? So is that changing anything?
Absolutely. In fact, like the innovations of SpaceX rocket being able to land, if we look at the numbers, we are talking about reducing like minus 90% of cost. Instead of like $1 million per cost, it goes all the way down to $100,000. This is how much cheap. And because of that, one of the example of impact we can identify, we have climate change. Sebab we can send more satellites, sebab it is very cheap. We can send more satellite, justifiable, and we can measure our Earth health. And with that, we can have more accurate data, another impact more. Just like how, actually the best analogy here is actually smartphone. Zaman dulu, phones is like very big, chunky, can only do phone calls. But with the progression of cheaper component, and also powerful components, more people can have smartphones. And from having like more people have smartphone cheaper, although ada yang mahal lah, macam iPhone lah kan. Apabila it is accessible, like smartphones being accessible to everyday people on earth, we have gig economies. We have Grab, Food Panda, and everything. It really multiplies the size of the market itself. Same, just like the innovation of rocket launching. When the launching itself is way cheaper, satellite can be easily not only accessible but implemented by many countries in the world.
Excellent. So we'll take a break on that note lah tentang global punya changes, dan maybe lepas ni kita boleh sambung balik dengan apa the impact on the Malaysian side, you know, in terms of our technology, in terms of the things that we need to learn about after the break.